Chapter 2.6 Algebraic Proof. You have been doing algebraic proof since the time you started algebra and pre-algebra, especially when you had to write every single step down, and some teachers made you tell why you could do each step, stating the property. We're going to go back to algebraic proof and revisit it for a while in hopes that it helps you understand the process of proof and other types of proof. So we need to review the properties algebra first. So we're going to let A, B, and C be real numbers. The first property is the addition property of equality, and that states if A equals B, then we can add the same amount to both sides. So A plus C equals B plus C. Subtraction. If A equals B, then we can subtract the same amount from both sides. Multiplication. We can multiply both sides by the same amount. And division, we have if A equals B and C is not equal to 0 because we cannot divide by 0, then A divided by C equals B divided by C. The reflexive property is stating that something equals itself. So A equals A, U equals U. The symmetric property states that if A equals B, then B equals A. It doesn't matter what side of the equal sign the expression is on. The transitive, if A equals B and B also equals C, then A equals C. Substitution, if A equals B, then A may be replaced by B, in an equation or expression. And the distributive is A times the quantity B plus C equals AB plus AC. And it doesn't matter what side of the parentheses the multiplication is on. So if I did the quantity B plus C times A, then it would still be AB plus AC. So let's look at the following algebra problem. And we're going to solve it, but we're going to justify each one of our steps. We're going to create a proof. So the first part of a proof is always the given. So you copy the statement or the equation down. And the reason for that was given. To solve this algebraically, the next step you would do is distributive. So 2 times 5 is 10, minus 2 times negative 3a is 6a, minus 4 times a, minus 4 times 7. And the reason for that was the distributive property. The next step you would do is combine like terms. So we're going to substitute the quantity negative 18 for 10 plus negative 28. And we're going to substitute negative 10a for the negative 6a plus negative 4a. And we're going to abbreviate substitution SUBS. We'll do subtraction with SUBT. The next thing we would do to solve this algebraically is to add 18 to both sides. And I want you to physically show that in these proofs. So I'm going to add the 18 to both sides. And I don't want you to write it below, I just want you to write it within the equation itself. And this was the addition property. Again, we're going to combine like terms. And this was substitution. The next step would be to divide by -10. And that's a division property. And then it'd be substitution with the result, which was a equals -11. And this is substitution. So we're given that d equals 20t plus 5, and we want to solve for t. So the first step is to do the given. To solve this algebraically, I would add 5 to both sides. Excuse me, I would subtract 5 from both sides. And this is the subtraction property. Then we would combine like terms. Which is substitution. To solve this next, I would divide by 20. And that's the division property. Substitution after we combine like terms. But I wanted to have d come first, so I have to take one last step where I flip it around the equal sign, which is the symmetric property. Okay, so in the next proof, we're given that angle A is congruent to angle B. The measure of angle B equals 2 times the measure of angle C, and the measure of angle C equals 45 degrees. We want to prove that the measure of angle A equals 90 degrees. So this is our given. The first thing we have to do is change the congruency into an equals. So the measure of angle A equals the measure of angle B, and that's definition of congruence. Now we want to keep the measure of angle A. We do know that we want to end up with this, so we're going to start substituting in other things that we know. So we know that the measure of angle B is equal to 2 times the measure of angle C, so we're going to substitute that in. So the measure of angle A equals 2 times the measure of angle C, and that was substitution. Then we also know that the measure of angle C equals 45 degrees, so we're going to substitute that in. Measure of angle A equals 2 times 45 degrees, and that was substitution. Well, 2 times 45 is 90 degrees. So we're going to substitute 2 times 45 for 90 degrees, and that was substitution. And we're done. We proved what we needed to prove. We have one last proof. To do the proofs again, we need to write down what we know. So the first thing that we know is the measure of angle ABC, or what we're given, plus the measure of angle CBD equals 180 degrees. And that makes sense because here is the measure of ABC and here's the measure of CBD. They do form a linear pair, which is 180. We know that the measure of angle ABC equals 2x plus 10. So this right here is 2x plus 10. And we know that the measure of angle CBD equals x plus 50. This equals x plus 50. And this was all given. So since we're asked to solve for x, I need to replace everything in this with something that has to do with x. So I'm going to replace the measure of angle ABC with 2x plus 10. I'm going to replace the measure of angle CBD with x plus 50, and that equals 180, and that's substitution. Algebraically, we would combine like terms, so 3x plus 60 equals 180, and that was substitution. Algebraically, to solve this, I would subtract 60 from both sides. And the reason for that was subtraction property. Again, we're going to combine like terms, so I have 3x equals 120. Substitution. Algebraically, the next thing I would do would be to divide both sides by 3. And my final step would be substitution. 120 divided by 3 is 40, and that was substitution. So again, in this proof, I looked at this first statement here. I substituted in what I knew that the measure of angle ABC was worth or equal to. I substituted in the equality for the measure of CBD. Then I algebraically solved it, showing each of my steps, and I came up with what I was asked to prove, which was that x equals 40. And that concludes the lesson for 2-6.